Alright, now we have a full working module with our messages and queries, but there's something else that we can add to our module to be more informative for applications, and that's it emitting events during state transitions. Remember that we defined events.proto, where we define these three events for us, and let's add in the code the corresponding logic to emit these events whenever it corresponds. So this is in the message server in each of the state transition functions, the create game and make move. So I will add here the event create game emission, and you will add yourself the one for the make move. So to emit an event, you have to use the SDK context. In order to do that, we'll have to unwrap the SDK context from the context that's within our transaction. So we will have SDK context. The SDK context is going to have an event manager that will allow us to emit events during the whole transaction. Let's do unwrap SDK context. This should bring the import for this that we need is the SDK types. github.com/cosmos SDK Cosmos SDK types. It's going to be called SDK. Now we can wrap the context. It's going to give us an SDK context. And within this SDK context, we have an event manager that it's going to emit a typed event. And the type event that we are going to emit is a types event create game. This is again picking it up from the generated files from the proto. You see we have this Go file from protobuf.go. There we have the fields that we define in our proto, and we just need to fill it up with the game number, that is the new game number, and the player's information, new game player A, the same for the player B. And what other field? I think that makes it for, yeah, that's the event create game. Now do the same for the make move and the corresponding event, in this case the make move event. Where you will have to fill up with the game number, the player, and the move. Also keep in mind that there's an end game event with the game number and status that should be included once the status is updated. Here we should check for that. Now pause the video and add this corresponding logic. Here I added the corresponding logic to emit the event when a player submits a move. It will emit the event make move, and then we will check if the game has ended, and in such case it will emit the event end game. For this I created this function in the types for game that will check for the status, if it is any of the status expected to be a final status of the game. For example, if it is a draw or one of the player wins or the game is cancelled, it would be an ended game. So this will be useful for this kind of checks to be easier to read. So now let's see how this looks like in the transactions. Let's compile again our application to get the latest changes. And now we can start again our chain, and we can make a move with Bob right now and see if the event make move is emitted. So let's do RPSD transaction RPS rock paper scissors, and we are going to make a move to game index 1 with the option paper from Bob, and we'll have to sign the transaction and broadcast it. And now let's check for the transaction receipt. Transaction. Let's see the information that we get from the transaction now. So you will see here in the events, here we have an array of events with different attributes, and here we will have an event. This is the message, and this is the event that we just wired to our app, event make move. You can see that we are broadcasting all the information. The game number is the 1, the move that the player submitted is paper, and the player that submitted it is Bob's address. We can check again the status of our game, RPS game 1, and now as you can see Bob is winning. We have player A move and player B move, and we emitted the corresponding event on the transaction. As I mentioned previously, the query server is also exposed via HTTP, and this is defined in our query proto, where we define this, like the GET request for the HTTP for querying the game is using this path, for example. And we can test this, for example, with either curl, but also there's this extension, REST client extension, that it can be quite useful for you. I'm going to show you how to use it. First, you will have to install it, and then you have to define settings.json in VS Code. If you're using VS Code, make there a VS Code directory, and here we'll add settings.json, and here we'll define different environments for this REST client. The interesting thing about this is that you can define different endpoints, for example, for development and for localnet and testnet and mainnet as well. So let's say we can have a local configuration where we'll have a base URL, and this base URL is going to be our local host and the port for our API that by default is port 1317. We can check this if we go to our config. Let's do it down here and we have more space. So if we go to our RPSD, we have our config, and we look into the app.tom, we'll find the port 1317 to be used with our API. That will have to enable it as well. This is gRPC. Here is our API. As you can see, the address to listen is the port 1317. Right now it's disabled, but let's enable it so we can test it. So let's open this to edit this. Let's search for API and we enable it. So now we will spin up this HTTP server in that port. And here as well you can add different configurations, for example for testnet. So you can query also your testnet, and this would be, I don't know, your testnet node.com, and the same for mainnet, right? And if you have installed this extension, you can create a folder with the requests, and we are going to call it REST API client, and let's add a new file that's going to be our RPS module requests http, and here you just define some name of what you're doing here, get game, for example, and this is a get request, and we're going to use the base URL and the RPS v1 game. This is the path here that we define, right? And the index. So this is the path that we're going to use. In our case, let's test with the 1, and here we add HTTP 1.1 content type to be application JSON. And the base URL is not defined because we here have to set the REST client environment down here to be local. That's all the options that you define here, you will have it in here to define which one you want to point to. And now let's test this, how it works. So we can start again our chain, and now it's going to start the server in the port 1317, and let's see if we get the response. As you can see, this sends the response, and we get the corresponding response for the game that we requested. If we try to look for something else, we'll return null, but it will return an OK. So this will signal that that game with ID2 does not exist. So this is cool because you can perform this request faster than just typing the CLI command, and you're also testing that the HTTP API is working. On the same line, you can add the Comet BFT endpoint here, so you can also perform queries using HTTP requests, and can be also helpful to quickly check the status or the state of the chain. So we can add here as well the HTTP localhost and the port 2657. That's the default port for the RPC, Comet BFT RPC. Also keep in mind that if you change in the configuration a different port, well, you'll have to obviously point to that port. But for us, we are going to use the default one, and then we can add here another file to be Comet BFT.http. And here you can go to the documentation, but if you go to docs.tendermint.com, here in resources, RPC, and you will get all the endpoints that these come with Comet BFT out of the box. So you can subscribe for events, unsubscribe from specific events, and also you can get some information about the node, the health, the status, the blockchain, the block results. This is more at the consensus layer, and also you can broadcast transactions with this API and perform some ABCI calls as well. So let's try some of these. In our Comet BFT, let's add some comments on what this is about. This is Tendermint Comet BFT RPC endpoints. And let's add the docs. You can actually, I think you can point this to our local node, but I'm not sure. There are some docs where you can do this. But the good thing of adding it to our repo is that you will have there for development. You don't have to go to another site to perform these tests or these checks. So let's, for reference, add there the docs. And we're going to name this Comet BFT. And for example, let's check the health endpoint. And it's going to be something similar to this. But here we're going to use the Comet. And this is just /health. This health, there's status as well. Status. We can check status of the chain. Status. This is having too many curly brackets. This is just two. Just two. There you go. Here we can use also the query transaction that we are using to check the transactions received. Is transaction and the transaction hash here. So later on we'll query some transaction. But one that it's quite useful is the block results. That will give you the information about a specific block and if there were any transactions within that block results. So let's see. Let's start a node. Oh, it's already started. So we can submit some queries to this. So let's check the health. It's returning okay. It's not doing much. The status. For this to get the other one, we have to add a divider here in each of the formatting. So let's send a status. As you can see, we get some information of the node. This is at the consensus level. You will see the name of the network, what's the listing address, the peer ID, and some network information, what's the latest block hash, and the application hash, validator info, the who signed the block. In this case, it's just one validator, but for an production chain, you will have many validators here. And what else do we have? Block results. In our case, it's just going to be not much information, just some final block events. And then we can check a transaction. Let's see if we have still a transaction hash around here, the one that emitted the events. And we can see clearer. So here we get the hash. And let's paste it here and see if we can. Transaction hash cannot be empty. So we're missing something here. Oh, I know. We have to specify hash. It's a query parameter. And we have to add it. It has to be hex. Let me check that. Transaction by hash. Yes, you see the hash. You have to add the 0x in front of it, and then we can send the request, and we get all the transaction information. You see here the events emitted. The first one is related to the fees. This is default in every transaction. And then we get other attributes related to signature, to account sequence. This is managed by the account module that updates the account sequence on every transaction. And then you can see here the message that we submitted and the specific event that we emitted in our code. If you got to this point, congratulations. You have your custom module working with its corresponding state transitions and queries. But as we saw previously, it has a fault on the design that the opponent can read the other player's submitted move and can anticipate and win this game without any hassle. To do this, we will implement commitment reveal protocol, where the first transaction to make a move should be submitting a hashed move and then revealing it once the other player also submitted the commitment. To achieve this, we're going to do it through a chain upgrade. So let's look into the next module about how we can perform schedule upgrades to keep our network up to date and improve the user experience.